In this lesson, we're going to be using a calculator to help us find the trigonometric value. So we've done some previous work with that, so it's a return to that. So given an angle, we're going to find the trig value, round to 5 decimal places. All right, and the second objective in this lesson is to find the angle in both radians and degrees when you're given the value. So think about working backwards, again, round to 5 decimal places. Okay. So let's do this top set of problems right here. It says, given an angle, find the trig value, round to 5 decimal places. All right, well, with our previous work, I think we know how to use a calculator to assist us in finding the trig values of secant, cosecant, and cotangent. All right, so for me, what I would do first of all is I probably would start with putting my calculator in degree mode. It is there. And doing all the problems that have a degreed angled measure. So from our previous work, sine of 56 degrees, easy enough. Sine 56, don't need the degree symbol, enter. How many places? 5. So 0.82, 0.829, 1, 2, 3, 4. The 5th place, gotta look at the 6, that's a 4, 04. All right, I'm just going to go through and find all the degree measured angles and find those first. So look at this right here. This is cosine of negative 12 degrees. This is not cosine minus 12 degrees. It couldn't be because I need an angle that follows all the trig functions. So in that case, even though there's no parentheses here, there could be. Okay, but if there's not, I have to understand that that means the cosine of negative 12 degrees, not cosine minus 12 degrees. Because if I had cosine minus 12 degrees, I don't know what I'm finding the cosine of. So I'm just going to go through and find all the answers to the degree measured angles. So if you want to pause the video, do as many of these as you can, and then come back and check how you did. That might be a good thing to do. Skipping that one, that's a radian measure angle. Secant, 92.3 degrees. Remember, 1 or 2 things need to be shown. Either rewrite it as a fraction, 1 over cosine of 92.3 degrees. Don't forget the degree symbol. Or if you want to go straight from secant to cosine, keeping the same angle with the degree symbol to the -1. All right. So I'm going to move on. I'm not going to find that exactly. I think we know how to do that. I'll share the answers in just a second. I'm going to skip this problem for now. I'm going to go to this problem next. This is cotangent of negative 15.39 degrees. This is not cotangent minus because I wouldn't know what cotangent is without an angle. So even though the parentheses aren't shown, I have to understand that that does mean it's the cotangent of that angle. So again, this is equal to the fraction 1 over tangent of negative 15.39 degrees, or you could straight go from cotangent to tangent using the reciprocal key. I would skip this one for now. It's in radian mode. Once I change to radians, I'll do all the radian problems. That's radian. Again, that's degree. So cosecant's reciprocal is sine. Keep the degree measure and put the -1 on the outside. Same thing with secant of 7.4. Secant's reciprocal is cosine, so cosine of 7.4, raise it to the -1. You'd make sure you're in radian mode to find these problems. Cotangent would be tangent of 5.96 radians, etc. Cosecant goes to sine to the -1. So make sure and show at least one of the 2 presentations here that would allow us to find the answer on the calculator. Okay, at this point, I'm going to go ahead and share my key with you. So if you need to stop and check all your answers, you might want to go ahead and do so. Okay, coming back to our second objective. Okay, in this first set of problems, notice that we were always given a degree, given an angle. We were always given an angle, whether it was in degrees or radians. So that was the strategy we took up here to find the value. So notice that all of the answers right here were just numbers. There was no, for your answer, you didn't have a degree symbol. It's not a radians because you were given the angle and you were asked to find the value or the answer. Okay, so, but notice what we're doing here. We're doing the inverse. It says find the angle in both radians and degrees for the given trig value. So for this whole set of problems right down here, what we're given, okay, are the decimal answers. How do we work backward to the angle that we use to get that answer? All right, so let's take a look at that strategy down here to find the missing angle in both radians and degrees. All right, so for this first problem, it says the sine of what angle is equal to this value right here? Well, mathematically, what we want to do is we want to isolate, we want to get by itself theta. Now, you guys are used to solving 1- and 2-step equations. For example, what if I had 7x equals 35? And I wanted to solve for x. Well, we would do the inverse operation of multiplying by 7 and divide both sides of an equation by 7. And that would result in the answer we were seeking. Same thing here. For all these problems, we want to find the angle measure. Okay, so how do we find the angle measure? Well, we've got to get the trig function off that angle. So when I look at sine of theta, how do I undo sine? Well, we'll be studying this more, but to get rid of sine, we would bring in an inverse sign, just like the inverse of multiplication is division. So this is what I want to see for all these problems. So we want to get rid of sine. So I'm going to bring in an arc sine or an inverse sine to both sides of the equation. And that's written like this. Arc sine of sine theta equals arc sine of what's already over here on the right-hand side of the equation, which is this decimal. So notice all I did from this line to this line is I brought in an arc sine to both sides of the equation. Well, the arc sine of sine actually undoes the sine off of the angle, takes it off, and so we're left with theta equals, straight to your calculator, get an answer. I do have a sine key that's an inverse, and that's the key that's above just the regular sine key. So right now, what this means is I'm going to find the angle whose sine ratio is this decimal. So I'm trying to find the angle. So it's an arc sine of the answer. Arc meaning find the angle. Okay, so let's go to the blue keys now. So, and the mode setting is not as important here, but you want to know what setting you're in. So first of all, I'm going to mode. Looks like my answer that I'm going to get is going to come back to me in degrees. So remember, I'm finding an angle. So when I hit the second sign, I'm asking the calculator to give me an angle whose value is 0.70712. When I press enter, that's not just regular sine. I didn't put an angle in here. I'm trying to get an angle because of that -1 key. 45, I have to round to 5, 45.00107 degrees. So go ahead up here and put theta equals, because we know that's what we're finding, 45.00107. Don't forget your degree symbol. If you can't remember if this is degree or radian, well, just go back to the mode key and go, oh yeah, it's degrees. All right, so what is the other angle measure that I'm supposed to give? Well, what is 45 degrees is, and some change here, equivalent radian measure? Well, you could multiply this by 180 degrees over pi, that conversion that we saw in a previous lesson, but since we have the calculator available, let's just use that. So what is 45 and some change degrees equivalent radian measure? What I'm going to do is right here, I'm going to go back to the mode key, change it to radians, okay, and then I'm going to go back to the home screen, arrow up, grab that again. Remember, you're in radian mode now. So 5 decimal places, 0.78542. And this is radians. This to me makes sense because remember, 1 radian is about 60 degrees. Well, this is not 1 whole, it's less than 1 whole. So it should make sense that our degree measure angle is less than 60 degrees. So I always try and make sense of my answers if I can, if I have knowledge of how to do so. All right, so how do we check our answer? Well, if you wanted to, okay, what mode are we in? We're in radian mode. So we could go back and say, okay, what's the sine, regular sine key? We're checking our answer. Sine of what was the radian measure? 0.78542. Now it's going to be off a little bit, but that's okay. Yep, that's the decimal value. That's close enough to what we want. Okay, is my degree measure the correct answer? Well, I don't know. I mean, 45 degrees goes here. Let's see. So I'll go back to my mode key, change it to degrees. I'm just checking my work. What's the sine of 45.00107? I don't need the degree symbol because I'm in degree mode. Yes, I get that decimal close enough. Okay. So when I scan down the rest of these problems, we're going to take the same approach. We're going to have a little hiccup when we get to those trig functions that we don't have keys for. So right now I can do cosine, tangent. I'm going to have to do some other stuff to this cotangent problem to get an answer. Secant, cosecant. So it looks like these two right here are the only ones that are going to be kind of straightforward. So we'll accomplish those, and then we'll look at several of these down here and how to tackle them since we don't have those keys in our calculator. All right, what angle has a cosine ratio of this value? Well, let's go ahead and show that we're bringing in the arc cosine to both sides of the original problem. I'm gonna go ahead and put that in parentheses. Remember, this is not an angle, this is a value. We're finding the angle in both radians and degrees. They undo, theta equals, I'll just re-record this. All right, so now I have to come up with two answers. I'm gonna go to my mode key. What am I in? Degrees. Okay, go back to the home screen. Second cosine, negative 0.93641. All right, 159 degrees and some change. So the angle measure that has this cosine relationship is 159.45715. Don't forget that's degree. I could check it real quick by hitting cosine. If theta was this angle measure, I could check it real quick. I'd probably go back up and pull the answer down. That would have been probably smart. Oh well. I'm in degree mode. Yes, that is the trig value that I wanted. So now what do I want to do? I want the radian measure that's equivalent to this degree measure. I could multiply this answer that I got by pi over 180 if I wanted to. I hope I said that back over here. Multiply by pi over 180 degrees. Hope I didn't say 180 degrees over pi. Anyway, or let's use the calculator. Let me come back up here, grab what I want. I think I was right here. I'm going to go ahead and press enter. Oh, that might have been too soon. I want to change my mode. Let me see if it's not too late. It is too late. No, maybe it's not. Let's go to radian. So now let me quit. I'm in radian mode, arc cosine. Okay, so 2.78305 radians. These are both angle answers. One's in degrees and one's in radians. Okay, remember that 1 radian is about 60 degrees. So this is a little more than 2 radians, so that should be more than 120 degrees. It's closer to 3 radians, which is about 180. So these answers make sense. Okay, so you guys attempt this one right here, tangent of alpha. Now instead of theta, we're just using a different symbol that represents an angle. But again, we don't know what the angle is. We're going to find the angle answer in both radians and degrees. So alpha equals, so arc tan, we'll undo the tan, alpha arc tan, negative 2.39. Undo. Excuse me. I'm gonna check my mode. I just like to start out in degree mode, but you do whatever you want to do. I just like to make sense of the degree measure. Arc 10. Remember, this is a value, not an angle. This could only be an angle if I didn't have the -1 here on the trig function. Oh, it's a negative measure. Negative 67.29508 degrees. We'll go back to mode, change it to radian. come back up here and grab this, press enter. So theta equals negative 1.17452 rads. Okay, those are pretty straightforward, but what happens when we look at the rest of these problems here, notice that cotangent, we don't have an arc cotangent, we don't have an arc secant, we don't have those keys in our calculators. So how are we going to overcome that and find the angle answers for those problems? Well, it's going to require an extra step. I hear somebody in my house. All right, so let's look at the cotangent of an angle called beta is equal to 2.36. What angle beta has a cotangent ratio of 2.36? All right. First thing I'm going to do here is try and get rid of cotangent and put it into one of the trig functions that I have on my calculator. So a little extra work here. Remember that cotangent, okay, its reciprocal is tangent. So I could take cotangent of beta and rewrite it as 1 over tangent of beta, and then just bring over 2.36. Next thing I want to do is I want to get tangent of beta out of the denominator. So if I did cross multiplication, okay, I'm going to get, that's one way to do it. I'm not going to do that from now on, but if I do cross multiplication, I'm going to get 2.36 times the tangent of beta equals 1. If I want to isolate tangent of beta, I would divide by 2.36. So that would result in my having tangent of beta equals 1 over 2.36. So notice that I accomplished getting rid of the cotangent issue since I don't have that second cotangent key. But now I'm back to a tangent problem, which I know how to handle here. Okay, so at this point, we would just continue the way we did over in the previous problems, bring in arc tangent, go to the calculator and find our answers. So maybe you've seen an easier way to go from the problem that we have to a different format so I can go to the calculator. Notice that if I change cotangent to tangent, avoiding the fraction situation, if I change cotangent to tangent of beta, then I would have to reciprocate whatever value is over here. Put 2.36 underneath a 1. All right, bring in arctangent on both sides, so it's going to end up looking like this. Okay, let's go to our calculator. What mode were we in? Okay, whatever. You can, stay in whatever mode you are. Just be aware of what mode you're in. So second tangent, I need a fraction. I just like to start with the degree. Oops, I'll probably delete that. All right, that's degrees. So beta equals, label your answer, beta equals 77 degrees. Again, if you wanted to, that is a degree measure, so you could multiply by the fraction pi over 180. It just seems like more keystrokes to me than changing the mode. Remember that conversion to change from degrees to radians? So beta is also equal to the radian measure 0.40079, and that's radians. That's an angle measure, so I like to put radians on there to remind me that that's not a value. Okay. All right, I might go back and just double check to make sure that my conversion is correct to remind myself. So I would go back and change the mode to radian. I'd come back up here and grab the problem and hit enter again. And yes, I do get the same value, or excuse me, the same angle in radian. Okay, let's set up one more. And then I want you guys to practice the rest on your own, and then I will display the key. Let's see. Well, we can set up a couple more, and then you can just go to the calculator and find the answers. Okay, what about secant of alpha equals this value? So what angle alpha has a secant ratio that gives us this? Well, secant is not on the calculator, nor is second secant. So I know secant's reciprocal is cosine. So I would rewrite secant as cosine of alpha equals, but if I reciprocate on this side of the equation, I've got to reciprocate on the other side of the equation. Okay, bring in arc cosine to both. So the setup is going to be alpha equals arc cosine of this fraction. Go to the calculator, find two answers. All right, let's do this. We want to find this angle. We do not have a second cosecant key, but I know sine of theta is the reciprocal. So if I reciprocate the left side, I've got to reciprocate the right side. Now, that's not a negative. I was just underlining the angle. Arc sine on both sides of the equation to isolate the angle. Got some calculator work in front of us. Don't forget to report both theta in degrees, labeling it degrees, and then radians as well. I'll just set up this last one and then display my key. Here, this is tangent of theta equals, if I reciprocate the left side, I've got to reciprocate the right side. So make that a fraction and flip it. The setup in the calculator is theta equals arc tan of negative 1/5. So at least show the setup so you're ready to just go right to the calculator. Alrighty, if you haven't paused the video yet, please go ahead and do so, and then attempt to set up and solve for the rest of them, and I will display my key. We already did one in the top two, so I'm going to slide it up a little bit. There we go. All right, so in this lesson, we learned how to use our calculator efficiently to find trig values, but then also find angles given trig values.